Okay, so this is section 2.3, day 2. Just want to cover a couple more problems here before we move on to the next section. It says in 2005, about 594,000 people received a master's degree, and by 2010, this number had increased to 659,000. Find the percent change in the number of master's degree received or over this time period. So this is a percent uh, relative change problem. Okay. So basically what you need to do is you need to use this formula. So it's basically the new minus the old divided by the old. Okay. So basically the new is the most current data minus the old data and then divided by the old data. So you want to put this, just caution, make sure that this is in parentheses when you type it in the calculator, or do that first and then divide it by the old. So don't try to do it all in one shot because you will probably get it wrong. Okay. So it tells me, so 2010 is the most current, right? So I would put, information from 2010 here, and then old will be the 2005, and then divided by the 2005. Okay. So in this case, the new information they gave us is 659,000. All right. 659,000 minus the old, which is 594,000, divided by the old 594,000. Okay. Okay, so um, when we do that, what do we get here? And then try it around to 4 numbers after the decimal. Okay, so when we put this in the calculator, we get 0.10994. Okay, 0.1094. All right, and then it says find the percent change. So all we need to do is multiply this by 100 to find the percent change. And then we get 10.94%. Okay, so that is the percent increase. Okay, question on that one. Okay, this is nice because it tells us the year, right? So what happens if it doesn't tell us the year? So for example, the next problem here, okay, it just gives us numbers. So how do we know it's the new one, which is the new data versus the old data? Okay. So it says here, calculate the percent change if the price of an item increases from $1.20 to $1.50. And then calculate the percent change if the price of the item decreases from $1.50 to $1.20. All right, well, this one's pretty obvious that the $1.50 will be the new one and $1.20 will be the old one, but sometimes it's not that obvious. Okay. But when you do this, though, if you are going from $1.20 to $1.50, that means it's a percent increase, right? So your answer should be a positive result. However, if you do the one down here, when you go $1.50 to $1.20, it is a decrease. So that means your output, the answer you should get, should be a negative percentage because it has a decreased. Okay? Well, that tells you that it's decreasing. So so that's a good way to check whether you are doing this right or not. So in this case, again, we don't have a lot of time during this lecture because we have a lot to cover, but I'm going to increase. So in this case, my new value is $1.50. My old value would be $1.20. So 150 minus 120 divided by 120, right? So new minus the old divided by the old, okay? So when we do that, we get 0.25. Let me see here. Let me double check that. Okay, so we get 0.25, but again, relative change is a percent change, so that means our output should always be a percent. So we multiply this by 100 or move the decimal 2 places to the right, and you get 25%. Okay, so it's a 25% increase based off of this information. All right, now if we were to do the other way, right? So as I said, if we're going to decrease, then my output should be a negative number indicating that it has decreased. So I'm going to have new minus the old divided by the old. So in this case, the new value I'm referring to is $1.20, and then the old value will be $1.50. So 1.20 minus 1.50 divided by 1.50. Okay. All right, so when I put this in the calculator, we get a negative 0.2. And then multiply this by 100 will give me a negative 20%. Okay, and that's what I want. I should have that negative number indicating that it is a decrease. Okay, it says here in 2010 there were 52,000 fewer US troops in Iraq than there were in 2003. If the total number of US troops in Iraq for the 2 years was 248,000, find the number of troops for each year. Okay, so this is how I would set it up. So remember, this is we're talking about linear equations here. So um, there's always going to be some x, okay? And um, and then we need to compare that, whatever information we got, compare that to x, okay? So in this case, for example, we have 2003, we have 2010 information. Okay. So if we go back and read this, and of course we also have our output. Okay. So in this case, it says if the total number of US troops in Iraq for the 2 years was 248,000, find a number for each year. So my output is 248,000. Okay, that's my output. Now that's the max, right? So in 2003, we don't know, right? It says there were 52,000 fewer US troops in Iraq than there were in 2003. So I don't know how many troops there were in 2003. But in relation to X, right? If X represents the troops in 2003, how would I describe this in terms of X for 2010? How would I write that? If they said there were 52,000 fewer US troops in 2003. How can I represent that for 2010? Yeah, so exactly. Yes, exactly. So it's going to be X because it minus 52,000 because it's 52,000 fewer than before. So X would be the bigger number, right? Because that's how much we had originally. Then then it went down. So we want to subtract. So X minus 52,000. Okay. All right. And then we just add these guys up equal to 248,000. Then combine like terms. So I combine these guys, it gives me 2x minus 52,000, 24,800. Then I'm going to add 52,000. I get 2x and we get 100 and so these cancel. 2x equals um 250,000. One second. I'm sorry. This should be this should be 300,000. I was looking at the wrong item here. All right, so 248,000. Let me read through that. Should be another zero here. There we go. Plus. Okay. So that gives us 300,000. Okay. Then we can divide by two, right? And then we get the 150,000. Okay. So for 2003, this is 2003 number. Okay. We had 150,000 troops. And in 2010, right, we just take the 150, right, and then subtract it from the 248,000. Second here. Sorry, my bad. You take the 150,000, subtract it, and subtract 52,000 because X is this here. So minus 52,000, right? So this is for 2010. So we get 150,000. That's what we have for X minus 52,000. Okay. And that gives us 98,000. Okay. All right. So this is for the 2010 year. All right. So if we were to add the 98,000 and the 150,000, we should get the 248,000. Okay. So that's where the 248,000 comes into play, is when you add the 98,000 plus the 150,000. And that will give us the 248,000. Okay. All right. But anyway, so the answer here is for 2003, it was this much. And then for 2010, it was this much. All right, it says here a plane is 300 miles west of Chicago, Illinois, and is flying west at 500 miles per hour. How long will it take for the plane to be 2,175 miles west of Chicago? Okay, so this problem is a distance equals rate times time problem. Okay, so distance equals rate times time. All right, so this is the formula you will need for this. So the distance, right? The distance is 2,175. All right. So distance 2,175. However, as you see in the picture here, 300 miles, right? Um, the plane already flew 300 miles. So the distance we need to decrease, right? Because we don't need to go the full 2,175 because the plane already flew 300 miles of it. So 2,175 minus 300, okay, that's going to give us 1875. Okay, so 1875. So that's how much is left over, right? 1875. That's how much the plane needs to still fly. So this is the distance, 1875, okay? And they're asking how long will it take for the plane, okay? So how long will it take for the plane to go to west of Chicago here? So our rate, R, is the 500 miles an hour. So this is going to be 500 miles per hour. Okay. And then T, I don't know what that is. That's what we're looking for. How long? T is time. Okay. And then I just solve for T. So we divide both sides by 500. Okay. So we get 3.75 hours because this is in hours. Okay. Hour. So 3.75 hours, that's going to be our T. But we need to convert that to hours and minutes in case the lab doesn't accept this answer. So you know there are 60 minutes in an hour, so we can just take 0.75 and then multiply that, right? So there are 60 minutes per 1 hour. So that gives us 45 minutes, right? Because this is minutes here, and this is hour. So the hours cancel, leaving us with 45 minutes. Okay. So in this case, it would take this plane 3 hours and 45 minutes for the plane to get to west of Chicago. All right, it says here an athlete runs 8 miles, first at a slower speed and then a faster speed. The total time spending running is 1 hour. If the athlete runs 1/3 hour at 6 miles per hour, find the second speed. All right, so again, we have distance equals rate times time. We're going to use this. So the first part of this, right, it says if the author runs 1/3 hour at 6 miles per hour, right? Because there's two phases here. Okay. It says first at a slower speed and then at a faster speed. So the slower speed is runs 1/3 hour at 6 miles per hour. Okay. So in this case, we need to compare the two, right? So you have the first hour, or I should say the slower speed versus the uh, faster speed. Okay. And then you have your outcome. So we know the total distance for the slower speed and the faster speed. They told us that the athlete runs 8 miles. So that's your total. Okay. And for the first one, all right, do we know how fast the person was going on the slower speed? How fast was the person going at the slower speed? Exactly 6, right? Hopefully everybody got that. So 6 was his lower speed. Do we know how fast the person was going on the faster speed? No. So that's going to be our X or whatever variable you want. I'm just going to put R for the rate. Okay. So 6, you know the rate, faster we don't know. So that's going to be R. Okay. What do we know about uh the six miles per hour? How long did that take? Okay. Yes. So 1/3 of the hour, right? Because um you have a full hour. The first part of it was 1/3, so that's going to be the time, right? So this is your rate, and then time. Okay, so it says 1/3 an hour. So 1/3 is our rate. And then for the second one, what would this be? What do I multiply this by? Exactly, the other 2/3, right? Because 1/3 plus 2/3 will give us a whole 3/3. So we have 1/3 here. The faster ones has to be 2/3. Okay. All right. And then so we just add these guys there and then equal them to 8. So 6 times 1/3 is going to give us 2. And then we have 2r/3. And multiply this equals 8. Okay, and then we just solve for r. So we're going to subtract 2 on both sides. So that's gone, and we have 2/3 3 equals 6. Okay, then we're just going to multiply by the reciprocal, say 3/2. That's the reciprocal. So it's 2/3 the reciprocal, that is 3/2. It was 5/3 the reciprocal, that would be 3/5. Okay, so just the opposite. Okay, so in this case, our 3's cancel and our 2's cancel. So we have r, and then 6 times 3 is going to be 18, and divided by 2 will give us 9. So our rate is 9 miles per hour. All right, just want to make sure we're on the same page here. So we got the 2/3 because the first part was 1/3. So the total was 1 hour. So we already used it 1/3. So what can we add to 1/3 would give us 1 hour? Well, it'd be 2/3 because 1 plus 2 is 3, right? So 3/3 will give us 1 hour. So that's where the 2/3 come from, okay? Because it has to add up to 1 whole hour.